lot of our customers are embarking on AI and ML journey. Pretty much every customer you talk to should be doing, if not. For folks who do not know me, this is Subhaya Sundaram. I run products for HYCU. I want to introduce the section and I want to pass it on to the speakers, David Noy and Satya. Every customer, there is a stat, you guys must have read about it. 80% of the company enterprises are supposed to actually have or expected to have an AI-based solution before end of the year. Why is that actually important? If they're going to come up with a production service, it means they got to keep the data safe. That's a requirement. It's not a nice to have, it's a must have, because now you're running a in production service. That's where it comes down to it. And people talk about AI, most people think of Gen AI, they just think of, oh, the chat GPTs of the world. There's a lot more to it than that. You guys know that. It's not, people don't always think of. That's where I want to invite our friend David Noy to first set the context on what does he see as some of the needs for customers protecting the data. And then Satya will walk through some of the things we can do. David?
Thanks.
Thank you.
All right. Thanks. Yeah, so look, David Noy again, VP of Products for Dell for the data protection portfolio. Dell is the industry leader in providing AI servers to customers. And what Subhaya just mentioned is the importance of protecting AI. Look, when we talk about AI and data protection, there's all kinds of cute things you can discuss. Chatbots that help you figure out what commands to run. People try to do analytics on your backup data. I'm curious how that's going to come out when you have multiple versions of a document and which answer you're going to get. But that aside, at the end of the day, when we were thinking about the AI factory at Dell, you've heard this announced, Dell has AI factories that we sell. We asked the question of, well, why do people protect AI data? Because if you ask, do you protect AI data? One of the common answers you get back is, well, you don't need to protect AI data because you can just recreate the answers. Well, it's kind of true, but kind of not true. So you put yourself in the mind of a large enterprise. Think of a top 10 bank. Think of any regulated industry. And there's a couple of use cases that pop up. Number one is cyber resilience. So if I take the training data or I take the results of inference and I poison them in some way, shape, or form, I can actually modify your models. I can modify your training data. I can modify your results. So look, cyber attacks happen. They're getting more sophisticated. The ability to go and recover back to a specific point in time is critical. That's motherhood and apple pie stuff. But let's talk about some other interesting reasons. Workload state. So let's say that you start to get performance variations and drift in the way that your models are behaving. And you want to get back to a specific point in time. And you want to revector potentially. Well, revectoring requires you to go back to a specific point in time. And if that means that you have to know what the state was, including all the configuration parameters that were used in the time that the vector database was created and models were basically trained, this is another way to go back. Another interesting one, put yourself in the minds of a large enterprise. Legal protection. How do I prove that the training data that I used to train a model didn't have personally identifiable information or some sort of IP infringement because I'm using someone else's intellectual property in my training models? The way to prove it is to back it up. If you want to do that cost effectively over time, data protection solutions like the Dell data domain plus backup vendors like HYCU make a lot of sense. Actually, I'm also going to start to believe that compliance is going to start to kick in. So the data that you use, oftentimes there's compliance requirements to keep data for multiple years, 7 years. How do you do that cost effectively? And not just the data that was used for training, data that came out of inference, not just the inference results, but also the prompts that were put into a system and the results that came back from prompts. So in some large financial institutions, every text message, every message that goes across the wire in any way, shape, or form is actually kept and retained for compliance reasons. So you can go back and say, hey, when I had this conversation, here's what was discussed. That's an important reason as well. And then data set reconstruction. So one of the interesting things, and again, we're at a cloud field days, if I'm going and I'm pulling training data, I'm potentially pulling it from multiple disparate sources. Might be O365, might be some on-prem NAS environments, might be whatever, you name it. Multiple workloads, vector databases are being produced. You have databases like MongoDB, Postgres, Elasticsearch is used in keeping track of where things are, in the processing of the training job. All of these different data sources, whether they're training data sources or config sources or databases that are used in the process of creating a model, potentially need to be reconstructed in the case of catastrophic data loss. And so how do you go back and make sure that you have a consistent point in time across multiple disparate data sources where they weren't all residing on one piece of infrastructure? And that's the answer. So I just wanted to give you some of the context of why it's important. Now let's go into a real life example. So this example is a large retail grocery chain. And in this particular case, we're talking about data sets that existed in object storage on-premise, object storage off-premise, large database as a service provided by one of the cloud service providers. We're talking about multiple tens of petabytes of data across different cloud providers as well as on-prem. And so again, what the value of a HYCU Dell relationship here is that HYCU provides the knowledge of those cloud database as a service vendors. It knows how to read those object storage, whether it's on-prem or in the cloud, and basically take what is essentially a combination of, you saw here, procurement, manufacturing, pharmacy, inventory, all kinds of different documents, images, config files, you name it, and basically be able to pull that together to use for, in this particular case, it's used for an AI use case, but you saw the reasons why you would want to do that on the prior page. And then we protect that and store that, and again, massively reduce it. So 15 petabytes on-prem, we saw multiple petabytes going off-prem as well. And at the end of the day, we want to make sure that that's really resilient. This is a customer who's been a long-time Dell customer, so they understand the value of the data domain product, but they need to be able to get access to all of those workloads that go into that AI training environment. Okay, makes sense? All right. Thank you.
Actually, I do want to just, what's interesting is looking at like I literally just to check, I scanned the NIST framework and the RMF playbook for AI, and it's wild that in one side, there's literally 2 references to the words data protection. There's nothing about backup in there, but you highlighted something that's significant, like the revectorizing of a database it's brutal. And a lot of people are discovering this the hard way. They accidentally leak bad data into the training, and then they got to go back too far, or it's extremely expensive to go in. So they're literally weighing the risk of maybe it'll just kind of disappear inside. So I like to see this, and I think that's a really strong story that we may not have seen yet because people haven't hit that wall, but they're going to hit that wall, and there's nothing out there that's doing that.
I just want to add one quick thing to that, which is the NIST framework references it, but you're right, doesn't enforce it. The DORA framework in Europe absolutely enforces it. So it's very interesting to see kind of what's happening in Europe with data protection and how this is all going to play out there as well.
Yeah.
I think AI has been moving so fast, and we've been looking, as a tech industry, we've been looking at like, how do we build bigger GPUs and faster GPUs and put more bus speed into the onto the motherboard. And I'll give you a little insider baseball and just share something with you. Like when at last Dell Tech World, when we went up and announced AI Factory, they built a huge slide and they put servers and they put storage. They didn't put data protection. And I went and looked at it and I said, well, that's cool, but you have to understand the people who are doing this, these are going to be large enterprises with these kind of concerns. Like at the end of the day, they will get regulated by DORA. At the end of the day, they will have compliance requirements. And so we have to make sure that we think about things holistically. We have the portfolio to do it. And so once we start to have those conversations, boom, the light bulbs come on. Yeah. And so people are really thinking about this stuff.
Again, the goal here is to kind of walk you through what we see with AI workloads, kind of identify what a modern AI stack looks like, where is the data actually getting generated and whether we are following it, and what kind of trends we see with this ecosystem. And we'll also do a quick demo if time permits as well, right? So a typical AI stack, I think all of them try to do 5 things really in terms of stages, right? They ingest a lot of data, and that drives a set of trends in this ecosystem. And they ingest from files, they ingest from objects, databases. You've got data lakes and also real-time streams. And then you enrich. This is where a lot of the vector DB, vector embeddings come into play. You take raw data, process it, transform it, you create features out of it, so that you have an optimal path to training your data sets. And finally, there is training. And the training itself is a multi-day effort. It's not one that happens overnight. You throw data at it, you run your model, and then, yeah, you've got something to work with. It doesn't happen that way. People train, people tune, people experiment. And as the example you already used, there may be times where you run against a benchmark, you check explainability, and you later find out, even if all of those KPIs are met, you've actually exposed some sensitive information to that module. So you kind of have to go back and do a whole lot of this all over again. So training is a multi-day effort. In fact, some of the largest language models, they all kind of talk about 90-day to 120-day training window, even though you're throwing millions of GPUs or 100,000 plus GPUs in some of these cases at your workload, right? And then once you've built that model, you serve and you deploy that module somewhere, and that comes through our artifacts, container images, and you deploy them, and you've got an observability architecture around it. And finally, you use that model to serve predictions. That's really what all of this AI/ML is doing, right? You then give new data sets and ask questions of it, and then the model gives you answers. And all of this data is important data that an organization is looking to protect. So let's take an example of a Google customer, right? And I chose Google because they've probably got the most, modern data stack for AI, right? They're probably the most matured among the three cloud providers when it comes to the AI ecosystem. And where does the customer put all of this data? The training data comes from all over the place. They can choose to, go through a unified platform like BigQuery. Feature and vector data typically tends to be sitting in databases like AlloyDB or Firestore, BigQuery. You've got prediction input data that also, again, sits on databases typically. And the output data is either a stream, or again, if you're a web application, sits in a database or can actually sit in GCS as well. You've got model artifacts where there's a registry where you can store the model artifacts. There's metadata about the models that you can store. And there's also Workbench, which is effectively a GCE instance that is synchronized with BigQuery, that's got the ability to store code in GitHub and has direct connectivity to GCS as well, right? So there is a lot of data being generated at every stage of this AI lifecycle. And what we do with HYCU is ensure that all of these services are protected, right? So all these services I've listed here, we can actually auto-discover and protect all of these services through our system. And again, it's not just on Google. We actually support the largest number of services in both AWS as well as Google Cloud today. And the other trend I want to highlight here is the emergence of data lakehouse. In the example that David walked through, the major grocery retail chain, people are seeing value of a unifying platform where you can throw a lot of structured data and unstructured data and multimodal data and be able to point your AI training engine on top of that data set, right? So you need some place to store everything. And that's turning out to be data lakehouses, right? And what is a lakehouse? We've historically had something called data lakes, which is optimized for storage efficiency and the flexibility of being able to store lots of different types of data. And it can store at scale, right? But a data warehouse, which you've heard of BigQuery, Snowflake, Databricks, Redshift, all of these solutions, their warehouse, they basically provide a level of governance. They provide database-like capabilities on top of effectively data lakes, and that you can actually query and analyze data very quickly. What lakehouses do is actually build a system that can handle both store at scale, but also analyze at scale. And that's what these lakehouses do. And BigQuery is certainly one of them. Databricks actually pioneered this concept, and BigQuery is one of the largest lakehouses out there in the market. And again, in the example that the major grocery retailer, they actually store 85% of the data that they are looking to protect in the stack in BigQuery, right? It's because they're storing all of the training data there. They're using BigQuery for feature data. They're using BigQuery for prediction data. So it is becoming a single unified platform that is storing a lot of data related to AI and AI stack. It is a multi-billion-dollar ecosystem. Google doesn't disclose revenue for each of their services, but it is estimated to be between $3 to $4 billion ARR ecosystem for Google Cloud, and a significant portion of their data portfolio today. So it's not just one retailer using it; it is becoming the centerpiece of the data strategy for Google Cloud, right? And what I want to also highlight is, yes, this is emerging. People are throwing a lot of data at it, but your exposure hasn't quite changed, right? You still carry the same kind of exposure you carried when you were storing this data in multiple places, right? You still have the possibility of a deleted table. You still have the possibility of a Terraform query. There's a schema change, and you just end up going and deleting a whole bunch of tables and data sets. And these things do happen. And there are some inbuilt capabilities with some of these solutions where you can kind of go back to a 7-day window and change some of these things. But what if it's greater than 7-day window? You do need backup, right? And the other myth surrounding this type of workload is people see lakehouses and warehouses as a second copy, typically. And why that happens is because usually you're ingesting from another source, right? Again, lakehouses are challenging that norm. You're not just storing a copy of a database you already have. You're not just storing a copy of a file that you already have in Office 365 that is coming into BigQuery before it's being fed into an AI/ML model. We're actually seeing a lot of real-time streaming data sets being generated as well. All your IoT data sets, all of your sentiment analysis on social media, right? All of that is real-time stream. And that data is actually skipping any other data store. And they're landing straight into these lakehouses. So for some of these data sets, your only copy of data is in these lakehouses. And if you don't protect it, you don't actually have a way of getting those data back, right? So, and also, even if you do have another copy of data set, the cost of recreating that data set in whether it's in BigQuery or any of these lake houses is extremely high. You have to worry about ingestion costs. You have to worry about processing costs. You have to worry about ETL costs. You have to worry about egress and co-location costs because not all of your data is sitting in one location. So recreating this data set at will is both expensive and also takes a whole lot of time. Again, explaining why they should be thinking about backup of these workloads, right? So this is where HYCU comes in. This is where the HYCU advantage shows up for our customers, right? And again, when you support 80 plus workload, it is very easy to become a platform that is tailored for the least common denominator, right? Do something very simple, just dump everything and get it back. But that's not what HYCU platform is about, and I'll show that when I do a demo as well. The platform is flexible enough to understand the data set that we are protecting and ensure we deliver consistency, we deliver immutability, we deliver cross regional project protection, and also support a high level of granularity, both in terms of what we back up and as well as what we can restore within this data set. Right.
And I need to warn you that we are at time for the presentation, so please do bring it to a reasonably quick close. I don't think it will be time.
Yeah. Awesome. Will do. And the other thing I want to highlight is BigQuery is an ecosystem. It's not a workload. There are over 100 connectors to BigQuery that can read from all kinds of connectors. And again, having a broadest platform that supports 80 plus workloads allows us to actually not just protect the lakehouse, but also a whole lot of connecting ecosystem players that are out there in the market as well.
The final takeaway from the Lakehouse section is that HYCU has a patent pending technology around atomic backups that is something that has never been built in the industry before. And so, Satya, if you could just very briefly, in 30 seconds or less, let's just provide our friends here with an overview of what this patent means to the industry as we start to drive towards a world in which we are really, really providing end-to-end protection of AI. I think that ultimately is what we're trying to get to. And, there is so much jargon and talk about AI these days that sometimes we feel like we need to provide a lot of context because people aren't talking about the infrastructure. They're not, as David really pointed out nicely previously, at Dell even, they're building a whole AI factory. And then David said, wait a second, we got to protect this. These are enterprise customers. And so this innovation is something that we believe is going to change the way that people think about that protection of AI. So Satya, just really quickly, 30 seconds or less, and then we're going to wrap things up so you guys can all get onto your lunch.
Awesome. And so this is the customer spotlight that actually brought to us the problem, right? What they have is a 700 terabyte data lake house that's ingesting data from lots of different sources, and they're all segregated in different forms and different data sets, right? And they have dependencies across these data sets. So they came and told us that whenever we run backups, by the time we get to the fifth table, the first table is no longer in sync with the fifth table that I'm backing up. And I've got a 700 terabyte footprint, right? So today with cloud native capabilities, they can only export one table at a time, and they're all kind of out of sync whenever there is dependency. So what we built is we leveraged native time travel capabilities within BigQuery to line up all of these data sets to a single reference point. And from there, we back up so that you get an atomic backup where all your data sets are as of a certain point in time when you run your backups. And again, that's very, very unique to HYCU. And we have a patent pending on that particular solution.